All right, everyone. In this video, what we're going to do is we're going to walk through an initial screening for a binary logistic regression model. Now, remember from class that one of the benefits of logistic regression is fewer underlying assumptions regarding distribution of predictors and some things along those lines, but still always a good idea to go through and take a look at your data, get a sense for what your variables are looking like, and make sure that we don't have clear violations of some of the stuff that we do need to be thinking about in terms of our logistic models. So for this example, we're going to be using the set that we touched on briefly in class. Again, what we have here is we're looking at archival data, looking at defendants, homicide, people convicted of homicide, and whether or not they were sentenced to life or death. And then our variables here, our predictors, are going to be number of victim impact statements. So this is the number of impact statements presented by survivors to that are represented by the prosecution, the depravity, subjective depravity rating of the homicide, 0, not at all depraved, 100, super depraved, and then finally a categorical variable that captures the mode in which this victim impact statement was delivered. So 0 being none, no impact statement was delivered, 1 being it done in private, 2 being question and answer, and 3 being an open setting. So again, this is the handout we'll be working through as we're working through our actual data. So here we have our data, we have our ID numbers, our sentencing, our dichotomous sentencing variable, 0 representing life, 1 representing death, number of victim impact statements, depravity score, and then our categorical delivery with 4 levels of that category there. Okay, so what we're going to do first is want to go through and take a look at our descriptive statistics like we normally would do. Well, I guess we can go through and quickly search to see if we have any missing values. No missing values, so we're good. So we don't have any cases that we might need to exclude because of missingness. So now what we're going to do is we're going to go through and take a look at our descriptives like we normally would. We're going to take a look at number of impact statements and our depravity score here. We're going to save standardized values as variables so we can look at extreme values and then look at skew and kurtosis. Now, we don't technically have assumptions regarding the underlying distribution of our predictors within a logistic model. So we're fine if they're skewed or sort of funky looking, but still we know that our models still work best when things are reasonably distributed. Also wanted to go through and take a look at these distributions just to give us a sense for what our data and our predictors are looking like. So we're going to request skew and kurtosis here. So we're going to continue saving our standardized variables, and then I'll just hit OK. I've got things set up in a syntax file there, but you guys can hit paste. I'm going to hit OK. And here we see, let me close this out, nope, all right, and then I'll just run this up here. There we go, do over, we'll run this again. All right, so we see here that we are seeing that both of our variables, our number of impact statements and our depravity scores, are seeing clear evidence of positive skew here and some pretty extreme values of kurtosis, some positive kurtosis. So we're expecting some very peaked distributions here with some flat tails. But the one thing we want to do is go through and make sure that these values are all within range. So again, depravity 0 to 100. Number of impact statements is just a count variable, which we'll get to in a moment, but looks like our impact statement is 0 to 14. That seems high, but I suppose it's reasonable. Depravity 0 to 100, so we're in range there. So at least it appears that our data are at least plausible. So we can check off no missing values, and data within plausible values, although we are seeing that these getting some indication that there are some pretty severe non-normalities within this set. Okay, so what we're going to do is we're going to go through, always want to take a look at graphs. So we're going to go to Descriptives, Explore, and we're going to look at number of impact statements and depravity score. We're going to take this file name and now we're going to drop that down into our label cases by here. And then for plots, I'm going to ask for histograms, and then we're going to hit OK. You can hit paste. I'm going to hit OK. All right, so this is all stuff that we've got before, but what I'm interested in is what these histograms look like. And so here we're seeing number of impact statements. Now this is technically not a continuous variable. This is a count variable. Count variables are ordered categorical, and so this is not a great, there are probably other models that would better handle this, but even if we're treating this as a continuous indicator, we're seeing 0, 1, 2, 3, 4, 5, 6, and then we've got a case way out here with 14. So when I'm looking at this, my first question is whether or not this has been entered correctly. Whether this is a case that was supposed to be 4 and someone maybe hit 14. Now, we don't know because we don't have access to the original data, but if I was an investigator, that would be the number one thing that I would do, is go through to make sure that this was accurately entered, that this case here actually submitted 14 victim impact statements. For these data, we're going to assume that that's a real value, but definitely something that we would want to check. So again, if I go down through and I take a look at my box plot, seeing that we have a couple of cases here that are exceeding 1.5 times the interquartile range, but really this is the thing that we want to focus on with this distribution, is this case hanging out right up here. Again, the asterisk indicating this is more than 3 times the interquartile range, and it's obviously we've got a positively skewed distribution, but then this is the really problematic case. Okay, so that's our number of impact statements. So a few things we're catching here. Now our depravity score, this is also showing positive skew as we saw before, and the so positive kurtosis here. But what we've got is it looks like most of these cases are low depravity homicides with a couple of cases hanging out here towards the tail. And this puts us in a little bit of a pinch because we do have what looks like, and as we go down through and we look at our depravity or our box plot here, again, these are some cases that are falling beyond 1.5 times the interquartile range, but then we've got 1, 2, 3 cases that are far out, particularly this last one, really far out from the rest of the distribution. And so we're faced with a little bit of a conundrum here. Probably one of the things we might be interested in terms of a research question if we've entered depravity score is sort of for those really gruesome cases, if that influences sentencing to life in prison or death. And so we don't want to lose these cases because these are sort of rare extreme cases we probably don't capture a whole lot just because there's probably not a lot of them compared to run-of-the-mill homicide. I don't know. This isn't data I work with a lot. So, but we're noting these as extreme values and some and some positive skew. But we're going to want to think carefully about what we want to do with these. We don't want to just get rid of them because we'd probably be getting rid of cases that are really important to try and understand what we want to take a look at. But we also can't have things that are super extreme like that, or it at least runs the risk of having an undue influence on our model. So going to keep an eye on that. So we see distributions, and again, our logistic regressions don't have specific assumptions about what the distribution of our continuous variables are. That's why it makes these models a bit more flexible, but we are seeing some extreme values here. So what I'm going to do is I'm going to go through and I'm going to take a look, because we saved z-scores here. I'm going to go through, I'm not going to save z-scores on z-scores. Take a look at our distributions here. turn off skew kurtosis, and you go ahead and hit paste. I'm going to hit OK. And what we see here is that we've got z-scores for number of impact statements. Our max value is over 6 standard deviations above the mean. For depravity, our most extreme value is close to 7 standard deviations. These are really, really extreme scores. We've got 123 people, so I mean it's an okay size set, but it's not. I might still be concerned with values of this size and the potential influence. So if I go and take a look at my VI, the z-score of my VIS, so we've got things are looking reasonable until we get to this case with 14 impact statements. Again, that's going to be this case right here. Again, my first question is whether or not that's a real value or a miskey, but we'll assume that it is. And so this score is associated with this value is associated with the z-score of the over 6. That's problematic. So we need to think about what we're going to do with that. Again, if we go down through and we take a look at depravity, again, we've got this value with a depravity score of 41 is high in the raw distribution. 49 is getting really big. By the time we get to 73, that's getting close to 7 standard deviations above the mean. And so we've got just a handful of cases on both variables that we need to do something with, probably. Now, we could transform, but I'm not liking that a whole lot just because we don't really care about the distribution. The non-normality isn't such a huge deal for these data, given that we don't have assumptions regarding the distribution of our predictors with logistic regression. It's more of an extreme score value. So what I might elect to do, and what we're going to do in this case, is we're going to go through and maybe do some smoothing. This one's easy. Remember, sort of standard smoothing procedures is going to be situations where we take extreme values like this and we sort of move it down and make it one value above the next highest value here, right? So if we're going through, so what I'm going to do is I'm going to try smoothing these two variables. So I've got VIS and depravity that I'm going to go through and smooth. Okay, so what I'm going to do is I'm going to go to transform. I'm going to go compute variable, and I'm going to say I'm going to call this. What am I calling this? Depravity number R, depravity R. Okay, so I'm going to go number R equals number of victim impact statements. Okay, I'm going to hit OK. You're going to hit paste. And what this is going to do is it now just copies my number of VIS into a new recoded variable. I can do the same thing for depravity. Is that what I did here? Depravity R. Yep. Okay, so depravity R equals my depravity score. I'm going to hit OK. You hit paste. And in my syntax file, that's just this command right here. Okay, so what we've done is we've gone through and we've just basically copied these over into a recode score. Now what I'm going to do is I'm going to sort these, and so my the number of victim impact statements, I've got kind of a continuous distribution going along that's skewed but fine until I get to this case. And so what I'm going to do is I'm just going to reassign this case in my smooth variable a value of 7. Okay, so this is just, it's still the highest score in the distribution. It's just not miles and miles out, sort of over 6 standard deviations out. So we're going to give this a try in terms of a smooth distribution. So we're going to do that. So this is now my smooth variable for number of VIS victim impact statements. Okay, so now let's go through and take a look at our depravity score. Now this is a little bit more problematic because this is measured as a 0 to 100 continuous variable, and we've got sort of incremental like ones values here. Now I could set this equal to 1 unit larger than the next and sort of set that equal to 50, but we've got kind of a situation here where we've got our continuous distribution, and then we've got a case that's high, and then another one that's higher, and then one that's really high. And I'd like to maybe retain the fact that this is quite a bit larger than this and this. So what I might try and do with my smooth variable, so I've got continuous distribution until we hit 30, and then we've got this case with a score of 41. It's about 10 units higher than the next one, and then 49 is close to 10 units higher than the next one. So maybe if we call this 50, what I might do is I might, in my recoded variable, drop that down to 60. Okay, so we're just playing around with this a little bit here, trying to retain the fact that this is a very high value, and not just the highest one in the set, it's quite a bit higher. And the fact that we've got kind of a continuous thing going on, we're going to try this. So we've got a case of 30, 41, 49, 60. So if we think about this as 30, 40, 50, 60, it kind of retains the fact that sort of these are a little bit spread out. So this is what I'm going to try in terms of my smoothing these variables to try and address issues with the outlying values that we're seeing here in terms of our z-scores. Okay, so what I'm going to do now, and I'm just going to run this from my syntax file here because it's nothing new. You guys know how to do this. So what I'm going to do here is I'm going to rerun my descriptives, saving z-scores, looking at skew and kurtosis now for my two recoded variables. Okay, so I'm going to run that. And so what I see for my number of victim impact statements, this is actually looking okay now, right? I did have a value of my skew of close to 2. We're down to just a little over 1. Kurtosis on this in the raw variable was 12.2. We're now down to a little over 0.5. So that smoothing did a nice job. Again, we're not worried too much about the distribution of our variables or our predictors for logistic regression, but that's looking quite a bit better than it was. Depravity is still not great in terms of something that's looking like a reasonable distribution. Our skew has improved actually quite a bit. It started at 3.56 and it's now down to 2.82. Kurtosis was 19.5, now it's down to 12. So these still aren't reasonable values. They're considerably better than they were before, but they're still not great. What I want to do is I'm going to go through and I'm going to run my plots for this to go through and take a look and see what our graphs look like. And so I see my smoothed VIS variable is now looking definitely skewed, but it's sort of certainly reasonable. So it's looking okay. My box plot has a couple of values that are existing beyond, or a couple of cases that are existing beyond 1.5 times the interquartile range. But again, given that we're running a logistic model, this is looking pretty good to me. I'm okay with this. So I think smoothing did a decent job in terms of addressing our VIS variable. Our depravity scores, we pulled these in a little bit, but they're still out there, right? We've got kind of a semi-symmetrical distribution until we get out here on the ends. Now again, if I look at my box plot, things are looking okay here. I've got a few values that are existing beyond 1.5 times the interquartile range, but then I get these same three values, 1, 2, 3, all similar distance apart from here that are kind of sort of trailing off at the end. Now again, my concern with setting these as maybe equal to 31, 32, and 33 is that these are cases that are seem to be categorically different than what's going on here in terms of whatever went down in these homicides. And it's probably going to be hard to capture these. It would be the same thing if we were doing, say, maybe work with substance abuse and had some people who had really high levels of substance use. Those are actually maybe the people who we're most interested in, so we don't want to do too much with this. So what I'm going to do, so we've still number of VIS, this is fine. We addressed that. This is still not great, but let's go through and take a look at what we have in terms of z-scores. So if I go through and run descriptives on the z-scores of my smooth variables, go down through and I see, okay, for my recoded or my smooth VIS, we've got my highest value is about 3.3 standard deviations above the mean, which is big, but much better than it was before, kind of right on that border of p equal 0.001 in terms of a z-score. So, and again, given the size of the sample, I'm okay with this and the model that we're running. Now, depravity, this was associated with a z-score of close to 7 standard deviations above the mean. Now we're a little under 6, so it's better, but it's still not great. If we go through and we take a look at our actual depravities score or z-scores, our one case, our Shore case was, so that actually increased, which is what happens if you, that was kind of an okay value before. Now when you pull that in, now it starts to become more extreme. So this has actually gone up, as has this. This has gone down. So at this point, this is still not a great distribution. And again, I'm not worried about the distribution because I'm running a logistic model. These three cases do have the potential to maybe start dragging out and starting to influence our results, but I'm hesitant to screw around with them too much more, given that these values and how extreme they are probably capturing a subset of the population that I'm probably interested in representing in my analyses. So what I'm going to do is I'm going to leave these. We're going to continue to monitor these cases, and as I'm going through and doing my primary analyses, what I might do is run my analyses with these three cases, and then maybe drop those three cases and see what the potential impact is on my overall results. But again, I don't want to put my thumb on the scale too much, particularly given my assumption that if this was my research and I were doing this, that these would actually be quite interesting cases. Okay? So we're going to leave it at that. And so to say, all right, we've got not great variables, but we get a little bit more latitude with our logistic regression. All right. So that covers our continuous variables. One thing we want to do now, remember that in terms of our logistic models, particularly if we have categorical variables, is we want to go through and make sure that we have adequate coverage. What can happen sometimes with our logistic models, our cells can start getting really, really small, and if I don't have adequate representation, I can start to get into trouble. So remember that in this case, I have two categorical variables. I have sentence, that's a dichotomous variable, and number VIS, which is a categorical variable, nominal variable with 4 levels. So what I'm going to do is I'm going to go to Analyze, and I'm going to go to Descriptive Statistics and Crosstabs. And what I'm going to do is I'm going to look at, let's say, sentence as columns, impact statement as rows. You can flip it around, it doesn't really matter all that much. But then what I'm going to do is I'm going to go to cells, and then I'm going to ask it to give me both observed and expected values here, okay? Because remember, what we want is we want to have at least all of our cells in our pairwise crosstabs. We want all of our expected values for our cells to exceed at least 1, and no more than 20% of our cells to have expected values less than 5. So I'm going to request observed and expected and hit continue. That's all we need to do here. So you go ahead and hit paste. I'll hit OK. And there we go. Okay. So what I'm looking for is I want to make sure that in possible combinations of sentence and victim impact statements, Whoops, I did that wrong. Got the wrong variable in there. Whoops. So we go crosstabs, not sentence, VIS delivery. There we go. Okay. Oh, yikes. Not number. Sentence. Crosstabs. Okay. No, we want this. Columns here. There we go. All right, there we go. This is what I want. So we've got my two categorical variables, sentence, life and death, and VIS delivery, none, private, Q&A, and open. There we go. Sorry about that. But again, what we're really looking at is our expected count. So again, for our logistic models, we want to make sure that none of our cells have expected values less than 1. Okay. So here are expected values for none for life and death. Here, private for life and death. Q&A for life and death. Open, life and death. So we're good. We don't have any of these cells so sparse that we're expecting values less than 1 for each one of these. The corollary to this is we want less than 20% of our cells having expected counts less than 5. We actually have no cells with expected counts less than 5, so our coverage here is looking pretty good. Now in this case we only have 2 categorical variables. If we had more, we would want to look at all cross tabulations of all possible pairwise, just to go through and make sure that we don't have at least some indication of sparsely populated cells. But for this case, because we only have 2, we only have to run the 1 crosstabs, and then things are looking pretty good there. Okay. So to this point, what we've got is took a look at our continuous variables. And then also with this cross tabulation, I can go through and take a look at my total representation of life and death for my dichotomous outcome, 52 to 71. So reasonably, it's not balanced, perfectly balanced, but they're sort of good enough, is fine there. In terms of representation for each level of VIS delivery, 53, 19, 31, and 20. So it's not balanced. We've got really over twice as many in our none as as my smallest, my private. And then also open. So we've got an unbalance in my VIS delivery. It's not optimal. It would be nice if we had relatively equal representation, but it's not terrible. There's certainly worse things that could happen. So I just want to make note of that. That my frequencies and my categorical variables also are at least looking reasonable here. The balance of life and death better than sort of relative to the VIS delivery. Okay, so in terms of our screening to this point, so we've got accuracy, missing values. We've looked at our continuous predictors just to see kind of what those look like. We went through and we identified, after we did some smoothing, or we looked at our outliers, did some smoothing, still have some extreme values, but we're going to sort of tolerate those for right now. Coverage is looking all right. The next thing we want to do that's unique to our logistic models is we want to remember that we need to have some consideration that our continuous predictors hold a linear relation with our logit. Okay. Remember that at the end of the day, our logistic model is a linear regression model or a general linear model. We're just changing our outcome to a logit, and so we're predicting log odds instead of probabilities. But what we still need to do is we need to make sure that our predictors, our continuous predictors, hold at least some reasonably linear relation with our logit or outcome. Okay, and so again, pulling a trick from Tabachnik and Fidel, what we're going to do here is I'm going to first center my smooth VIS impact statement and my depravity scores, depravity variables that I created here. Okay, so these are my smoothed variables I created here. And so what I'm going to do is I'm going to center these. Again, if I go back up to take a look at my mean values here. So mean value for my smooth number or VIS is 1.4 or 1.4309. For my smooth depravity, mean value of 12.398. So that's what we just did here. So we're just centering, creating a centered impact and centered depravity scores here. So I'm going to run those. Okay, so I've got a centered impact, centered smooth VIS, centered smooth depravity scores here. I can go through, always good to say, all right. And again, if I've done this correctly, I should get mean values of 0 here. Yep. Okay. So these are just my centered versions of my smoothed continuous predictors. And then what I'm going to do is I am going to go through and I'm going to create the natural log transform of each one of these variables. Now, both impact number of VIS statements and depravity technically can have 0 values. Impact does, depravity doesn't, but technically it could. So what I'm going to do, and we can't remember that we can't take the natural log of 0 because we get an error. And so what I'm going to do is I'm going to compute 2 new variables. The natural log of my smoothed impact statement here. I need to. Yeah, I'm going to modify this here. Go through. Oh, whoops, no. What am I doing? Never mind, I had it right. Don't second guess yourself. All right. Remember that we can't take a look at our centered variables because those are going to be have 0 as their middle point. So what we're going to do is we're just going to take the natural log of my impact, and what I will do is make this in my smooth variables just to make sure everything lines up, and my smooth depravity score there. Okay, and what we're going to do is we're going to take the natural log of my smoothed VIS, or my smooth number, the natural log of my depravity, go through and do that, and so run those. Okay. All right, there we go. So what I have here is I have the natural log of my smooth depravity, or excuse me, my smooth impact, or VIS, the number of VIS statements. And so here's the natural log of that. Here's my depravity score, the natural log of that. And what I'm going to do, remember what we want to do is we want to make sure that our we don't have nonlinearities, my continuous predictor with the logit. And so again, borrowing from Tabachnik and Fidel, what I'm going to do is I'm going to analyze. I'm going to go down to regression. I'm going to go to binary logistic. And what I'm going to do is I'm going to put sentence as a dependent variable. And then what I'm going to do is I'm going to say my number of victim impact statements, my depravity, oops, drop those out. I'm going to take my centered impact, the centered depravity, and then what I'm going to do is I'm going to go through and in SPSS, this actually works. So what I can do is I can select my impact, and then hold Control and select the natural log of impact. And then if I hit A times B, it's going to create that interaction term for me. So I don't actually have to go through and calculate that. I can do the same thing for my center depravity. Hold down Control, select the natural log of that variable, drop that in, and then what I can do, the last thing I have is my VIS delivery. VIS delivery, this is my categorical variable here. I'm going to drop this down. So what I've got in my model is I have, just for this screening, I've got my centered number of VIS statements. I've got my centered depravity, and then I have the interaction of the natural log of impact and centered impact, and the interaction of natural log of depravity versus centered depravity, and then I have my VIS delivery here. So what we're going to do with this is we're going to want to see if these come up as meeting benchmarks for interpretation p less than 0.05. This starts to suggest that we may have some nonlinearity in my logit that would be problematic. But before I run this, last thing I'm going to do is I've got VIS delivery. This is a categorical variable. So if I go up to go categorical, and I tell SPSS that VIS delivery is a categorical variable, and I want, remember, if we go through, take a look here, we've got none, private, Q&A, and open. What we need to do is we need to tell SPSS what my reference category is. Right now, it's got the last reference, or the last category is a reference, so that would make open as the reference. For this, none makes more sense. So what I'm going to do is I'm going to say, well, for this indicator, I want the first level of this indicator to be the reference group. And so I'm going to click first and hit change. Okay. And what this is just doing is it's going to tell SPSS that this VIS delivery variable is a categorical variable. And what we want to do is model the first category, that is no VIS delivery, as the reference group for this. Okay. So I'm going to hit continue. So what I've got is I've got a model, and I'm running a logistic regression here, looking at impact, depravity, the interaction of impact and the natural log of impact, the interaction of depravity and natural log of depravity, and then my categorical variable here. Now, the only reason I'm running this is to test linearity in my logit, and what I'm looking for are low p-values for these. But a slick way to go through and test that linearity assumption, at least linearity between my predictor and my logit. Okay, so you all hit paste. I'm going to hit OK. All right, and here's my model, but I don't care. The only thing I'm going to care about here, going to go down to the final variables here, and what I'm going to look at are the p-values for these interaction terms. So the natural log of number of VIS impact statement times the centered impact smoothed, and the natural log of smooth depravity times centered depravity smoothed. And look at these p-values. These are both very large p-values, which fails to provide any real meaningful evidence of potential nonlinearities between my continuous predictors and my outcome, in this case, which is my logit. And so this little test here does a good job. Again, you can look at this in Descriptives. Does a good job of testing that linearity of the logit assumption, and it looks like we don't have any problems here. Okay, so this isn't a model that we would go through and take a look at and try and interpret. It's just these two values here that we're looking at. Okay, so linearity of the logit looks okay. The only thing that I am going to do now that I have left to take a look at is going to be collinearity. We still want to make sure that we don't have evidence of collinearity between our predictors. Now here we only have two continuous predictors, and so for these logistic models, what I'm just generally going to do is probably going to go down through and I will look at so my recoded number of VIS statements and my recoded or my smooth VIS number of victim impact statements, my smoothed depravity score. Okay, going to just look at bivariate correlations there. Hit OK. and I see that my two continuous predictors, or predictors I'm treating as continuous, have a near zero correlation between the two of them. So I'm not at all concerned about collinearity between my predictors. And here there's a good test because I've only got two of them, so we're looking pretty good on this. Okay. So at this point, that pretty much does it. Okay. Again, this ended up being a little bit longer, just because I had some funky extreme values that needed to deal with. But if I was going to go through and write this up, try and summarize everything using the structure that we've used in class, accuracy and plausibility, we're looking good here. Missing values, no missing values. You can use our full set of 122. Now with our univariate distributions, again, we don't have strong assumptions about the distributions of our predictors. It's nice if they're, and sort of our model performs best if we have nice normal predictors, but we don't need them. But what we do want to do is just kind of take a look and see what's going on. Here we saw number of VIS, strong skew and kurtosis, same thing with depravity. Giving a little description of our histograms and our box plots, noting that there's some problems here, or at least these are very non-normal. Taking a look at sentence, sort of reasonably balanced between life and death sentence in this set. Again, we got this value from our cross tabulations. Again, VIS delivery a little bit unbalanced for none, private, question and answer, and open. Again, got this out of my cross tabulations, just putting this in my univariate distributions. So this isn't balanced, so it's not optimal, but probably not too big of an issue here. Then looking at our univariate outliers, seeing this case here, D82, extreme value for VIS. Again, this was one we had someone who was reporting 14 impact statements with a z-score of 6.34. A couple of cases with extreme scores for depravity. Again, a z-score here of close to 7 with a score of 73. This case, z-score of over 4 standard deviations above the mean with an x of 49. So we're concerned. These are pretty extreme values. So what we did is we went through and smoothed, assigned this case a value of 7 for number of VIS. Again, this was just one a unit above the next highest in the set. And then what we did is we talked about, that's this person here is what we should be looking at. This case here, assigned this a case of 60. So brought it down a little bit just to try and retain that kind of even spacing across those. So it's pulling in a little bit, not a ton. When we went through and took a look at our smooth distribution, number of VIS, the smooth version of that was good. Depravity was still skewed and kurtotic. Still seeing some extreme values within smooth depravity. But again, what we decided to do is go ahead and continue with the smooth distribution. And as I would go through and run these analyses, would want to go through and take a look at the practical impact of these. I would probably run it with and without those 3 scores just to see how much of an impact those 3 cases with the largest depravity score are having. Coverage is looking fine. Didn't indicate, this should be coverage is sort of an error in my thing here. Coverage is looking good, seeing no values, expected values for no cells between my two categorical predictors, no cells with expected values less than 5. I'll correct that in the sheet that I'm giving to you all. So our coverage is looking good. Linearity of the Logit, interactive effects between continuous predictors. Not seeing any non-linearities there, so we're looking good. Multicollinearity, near no correlations. So pulling this all together, the things that came up in this screening really are number of VIS as a count variable. That's kind of problematic. VIS and depravity, extreme scores, violations of normality, VIS unbalanced, but sort of that's not a huge thing. So again, in our write-up, noting that our logistic models don't have a formal assumption about the distribution of our continuous predictors, but we've got some problems with extreme values. Okay, went through and smoothed. That took care of our VIS issue. Depravity was still somewhat problematic, but again, what we're worried about is starting to mask the potential impact of some of these rare but important values in my data. So we decided not to sort of throw these out. So smooth, they're still outlying values, but we're just going to go through and continue to monitor these. VIS delivery not balanced, but we're probably not overly problematic. We had adequate coverage here. And then, so at the end of the day, in addition to wanting to go back through and check our one VIS case to make sure that that was an accurate data entry, and that really was 14 VIS statements or victim impact statements, and want to keep an eye on those cases with high depravity scores. Only other thing we might want to do is consider using a model that does a better job of addressing count data, but at the end of the day, we can probably move forward with this and sort of, again, monitoring the situations that we've identified. So hopefully this was helpful. Again, as long as you don't have weird outlying values, screening for your logistic models is going to go quite a bit more quickly than some of our continuous variable models. But hopefully this gives you a sense for a framework for how to put this together. If you have questions, make sure to let me know. Otherwise, good luck and have fun with logistic regression.